You've probably heard somewhere that stars twinkle because of turbulence in our atmosphere, but to accept this explanation, you have to understand something critical, and that's that light doesn't always travel in straight lines. You've all seen this before when you take water and put a straw in it. You can see that the light that goes through the water is coming out at a different angle than the light that reflects off the straw up here. This is because the light actually travels at different speeds in different materials. And on top of that, it always takes the least time to get from place to place. This is called Fermat's least time principle, and technically it's an extremal time, but for our purposes, thinking about it as least time works great. But what does this have to do with mirages and stars twinkling, I seem to think you're saying? Well, both of these phenomena have to do with the way light passes through things. First of all, let's allow that light in a vacuum is when light travels the fastest. That is, when light actually goes light speed. If this is the case, it's reasonable to assume that things that are less dense, closer to a vacuum, are easier for the light waves to travel through. Now, this isn't always true, but for the most part, when you're thinking about a gas, it's good enough. Take a look at this. I mean, I know you've all seen water and oil before, and it's not that shocking that the oil floats on top. But what we really have going on here is two different indices of refraction. That's the fancy term. But all it means is that light moves at a different speed when it goes through the oil than when it goes through the water. So say this is the sun, all right? Or maybe just reflected light off of a mountain, something distant like that. When it comes through the air, we're going to use this to represent our air, where there's a layer of less dense air and a layer of more dense air, and the light is coming right along that interface, you get all sorts of bizarre, crazy bizarre separations of that image. And it feels a little bit like, you know, some sort of crazy mirror. Let's say a little gust of wind comes by and disturbs it. Wow. You see those secondary images ripple and fade because of the turbulence in the fluid. Now, what does this have to do with twinkling stars, you might ask? Stars don't just wobble around crazily. Well, you might know that they actually do wobble around crazily. The problem is that you're looking out of a tiny little hole in your eye. To prove my point about seeing through your tiny eye holes, we're going to do another experiment. This one with the stove. You're going to need stuff. Tape. You always need tape. Cards to poke holes in, a pokey thing. The ever-trusty laser. And a bunch of cups. We're in a kitchen. We can get cups, right? Like 2 shortish mug ones and a tallish empty one. This setup is to demonstrate why stars actually twinkle instead of just wobbling around when they go through different layers of turbulent air. So what we got here is our little toy laser, our favorite. It's taped on. You can see it's on. It's going through the first card with just got a little hole poked in it. You can see the light coming through on the other side. The reason I poked a little hole in it is because I want it to be a teeny weeny starlight, not like a big old planet, because believe it or not, planets do wobble around. And this star is coming down through the atmosphere of the air, and we're going to be doing something to make it turbulent here, down to where I am standing, or you, or whoever. You got to set it up so that the dot hits the card and still comes through. Oh, come on. Where is it? There it is. There's our little starlight. But we're going to need to dim things in here to make sure that we can get all of the cool lighting going on. So let's fix the lights. Ooh, spooky lights. So there's our star coming on the back of our retina. Here's our eye, with the starlight falling on the eye. And here it is hitting the wall, which would be like the back of your eyeball. And it's not really doing anything, because it shouldn't, because we're in a kitchen and we don't have turbulent air. So as you can probably see that I turned my burners both on high. First warnings, high hot burners, don't burn yourself or burn your house down or something. Keep an eye on this. What you do is you turn on both burners and you still have your setup with the laser on and it's coming through the little focusing hole. and it's coming through this air. And when we turn on the heat from these burners, the air is going to start swirling about. And you know that air swirls about. You've seen it before on top of your car on a hot day or on the sidewalk. And that's the mirage effect, is because of the temperature changes that are going on here. There's air flowing in and wiggling around, and it starts to affect things over here to the card, which keeps distorting from the heat, which is special. We want to distort the light, not the card. Yeah. Okay, so this is where it gets... Oh! So, you might set your fire alarm off. Ha ha. Okay. Right, anyway. Check it out. It's coming through the eye, onto the wall. There it is, twinkling. Can you see that? Look at it. Look at it. Look at it twinkle. There it is. See, twinkle, 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 twinkle. Because what's really going on, of course, the light is just kind of wiggling and shifting around. You've probably heard before that stars twinkle, but planets do not. And the whole reason we put this first card here was to bring the light down so it was more like a star. The thing is, all we have to do is move this away, and then you won't end up with a twinkling star any longer. There it is, see? That's like a planet. Now, if you just look at it, it still kind of wobbles and wibbles. So you can see here, it kind of wiggling around. So that is the reason that turbulence can cause stars twinkling. It's a combination. Why is this turning on? I didn't turn this fan on. Oh, it must have a heat sensor. My microwave just turned on because of the super hotness after I had my fire alarm go off. I turned the fan on for that. And then this has the microwave pulling up the fan. The fan just automatically came on. I can't turn it off. Look. Off, off, high, low, off, It's still going. So it must have some sort of a heat sensor in there because I left this on way too long. Safety kids. Okay, so I got my fan to finally turn off. Be very careful doing this experiment, but it's super fun. There's a lot of other videos online that do this sort of a thing. Like they talk about mirages and the way that light can bend and curve. But this demonstration really ties together the ideas about what a mirage is and the fact that a mirage is just light bending and shifting around, and the fact that combined with that and the fact that you have a very tiny hole called your pupil means that literally the stars are going in and out of your field of view and your focus all the time. And that's actually what leads to the twinkling of stars. You'll notice that twinkling stars are much more twinkly near the horizon than they are straight overhead because you're looking through less atmosphere overhead. I saw this demonstration when I was really little, and it just had a really strong impact on me in terms of the way that light really works. But you don't have to take my word for it because you can almost set your kitchen on fire too. I mean, really, be safe. You can science it. Starkle, little twink. Who the heck are you think? I'm not under the alkafluence of alcohol, though some think beep I am.